Hi everybody, this is Miss G. This is a quick lesson on percent composition. Percent composition is just the percentage by mass of all of the elements in a compound. And percent composition is sometimes used to determine the identification of an unknown compound. So here's a formula for percent composition. It's just the mass of an element in a compound divided by the mass of the whole compound times 100. Here's a sample problem. The following data are obtained from analyzing 2 iron oxide samples. So these might be rocks that a geologist has picked up. Using percent composition analysis, determine whether or not the samples are the same compound. I give you information about 2 samples. I tell you how much each one of them weighs, and I tell you how much iron they both have in them, and how much oxygen they both have in them by mass. I'm going to figure out the percentage of iron in both compounds, and then I'm going to compare those percentages to see if the 2 iron oxide samples are the same. So for sample number 1, I'm just going to take the mass of the iron, which is 28 grams, and I'm going to divide that by the mass of the whole sample, which is 36 grams. And I'm just going to multiply that by 100, and that gives me a percentage of 77.78%. And that's percent iron. Then I'm going to do the same thing for sample number 2. Maybe I'll put a subscript 2 here and a subscript 1 up above. So this sample has a lot more iron in it, but it's also a lot heavier. It's 112 grams of iron, and I'm going to divide that by the mass of the whole compound, or excuse me, the whole sample, which is 160.00 grams. And when I multiply that by 100, I get a percentage of 70%, which is actually less than the first sample. So I can tell by comparing these 2 numbers that in fact the 2 iron oxide samples are not the same, and that is the answer to the question. And the percentages are my evidence. Here's the second type of problem you're going to see. This question says, Caravone is an organic compound that appears in 2 forms that both have the same molecular formula, which is C10H14O. One form gives caraway seeds their smell, and the other gives spearmint oil its smell. The question starts here. Determine the percent composition of each element in 1 mole of the compound. Down below you can see I wrote down steps to solving this problem. It's pretty straightforward if you follow the steps. So the first thing I'm going to do is determine the molar mass of this compound. I'm going to go ahead and write that out. So what you see below is me figuring out the molar mass of Caravone. And you can see I just took the molar mass of each individual element. There's carbon, there's hydrogen, there's oxygen, and I multiplied by how many atoms were in each element were in the compound, and I came up with a molar mass of 150.24 grams. So the next thing I'm going to do is figure out the percentage of carbon in this. So all I do is I take the mass of the carbon, the total mass, which is 120.10 grams, and I'm going to put that on the top of my fraction. And I'm going to divide that by the mass of the entire compound, which is 150.24 grams. And I put that on the bottom. And multiply by 100. And that's going to give me 79.94%. So that's how I'd figure out the mass of the carbon. To figure out the mass of the hydrogen, the percentage of hydrogen, I just take the data for hydrogen. I take 14.14 grams, and I divide it by the mass of the whole compound, 150.24 grams. Multiply by 100, and I get 9.412%. If I were to figure out the percentage of oxygen, and I'm not going to write out how to do that, but if I were to do that, I get 10.65%. And the point I wanted to make is simply that if you added up the masses of all of these percentages, if you summarized or added up all of these percentages, they should add to 100%. It's a great way to double check your work. So these two examples should be enough to get you going on the next page, which is a worksheet on percent composition. Read the questions carefully, because in the questions I often ask you to calculate the percentage by mass of a really specific element, and you don't actually have to figure out the mass of every element in the compound. So you'll save yourself a lot of work if you read carefully. Second of all, I put the answers to the questions at the bottom of the page so you can check your work. Good luck, and talk to me in class if you have any problems. See ya.
Made with Doodlecast Pro.